Good evening, everyone, and welcome to this lecture on photoelectric effect. Now, why we have jumped onto photoelectric effect? Because this is a natural transition. We were doing wave optics. We have seen that light has got dual nature. Yes or no? What do you mean when I say dual nature? I mean it can act as a particle as well as it can act as a wave. There are some phenomena which we can explain both by particle and the wave nature. Particle mean ton, discrete things. Wave means it is continuous. Now, reflection and refraction were the topics where we started from. Reflection and refraction both could be explained both by the particle nature of light as well as the wave nature of light. Then we shifted to the next topic, which was wave optics, where we studied those phenomena which cannot be explained by the particle nature, they can only be explained by the wave nature. Superposition, interference, diffraction, and polarization. Now we jump onto a topic which cannot be explained by wave theory. It has to be explained by the particle theory. Photoelectric effect. Now, this photoelectric effect was observed by Hertz, and it was proposed by Planck, and then Einstein came and he gave his own additions to this. Now, this entire photoelectric effect, obviously, we'll come to know about this photoelectric effect, but right now it's time because it is the particle theory of light. We can understand the most important concept of this particle theory of light. Remember, now light is not a wave, light is a particle. It's a particle, just like an electron, a proton, a neutron, me, we are all particles. Light also consists of a particle, and the smallest particle or the packet of light is known as. Welcome to this new character, which is known as photon. Have you heard about photon? Yes or no? No or yes? Huh?
Yes, sir.
Now, photon. What do you mean by a photon? Light comes in packets. Biscuit comes in packets. If you go and ask shopkeeper, give me one biscuit out of the packet, he'll say, go find some other shop. I cannot give you one biscuit. I'll only give you a packet. Quanta or packet. You go to a fruit vendor and say, give me half of an apple. He will not give you half of an apple. He'll say, only take one apple or go. Packet. Light is a particle. It comes in packets, and the smallest particle of packet and the smallest packet of light is known as a photon. So that is the first principle of this photoelectric effect. It's not photoelectric, but it is a particle theory of light. From this particle theory of light, we will understand the photoelectric effect. Einstein's quantum theory or Planck's quantum theory says that light propagates in packets. One packet, one light, tongue, just like electron, tongue, proton, tongue, one peanut, tongue. Light propagates in packets, and this packet of light is known as photon. This packet of light is known as photon, and obviously this packet possesses energy because light possesses energy. Do we understand this? Yes or no? No, yes. Particle.
Yes, sir.
Trying to understand light as a particle. So now, from wherever or whenever we are going to think of light, we are going to think of it as particle. A number of particles are falling. If light is falling on something, we will not take it as wave falling on something. We will say that a number of particles, which are known as photons, are falling on a particular body. Light propagates in photons. Now, as soon as we come across this word photon, the first thing that we must understand about this term photon is how much energy this photon has. How much energy this photon has. We define that energy of one photon as E, and this energy is given by H multiplied by F, where what is H and what is F? E is obviously energy of one photon. E is the energy of one photon. H is something new. And this something new is known as the Planck's constant. H is known as the Planck's constant. Have you heard about Planck's constant?
Yes, sir.
Remember this Planck's constant, remember this unit, and remember the dimensions, because I have seen a lot of questions come on this Planck constant H. So remember its dimension, remember its unit. You must also know its value. Value will be given to you in any case. What is the value of this Planck's constant? 6.6 into 10 raised to the power minus 34 joule second. This H is known as Planck constant because Planck proposed this theory of quantum theory, Planck's constant. F. What is this F? This F is the frequency of the photon. So energy of the photon can be found out from this revolutionary formula. E is equal to HF. H standing for the Planck's constant and F standing for the frequency of this photon. Now this formula for energy can be written in a different way. To understand this, you have to understand that C is F lambda. Now this photon, since light consists of photons, these photons are moving with a speed C in vacuum. Do we understand this? And this C speed, frequency F and lambda are related like this. So from here I can find out the value of F and I can write it as C by lambda. I can put this value in the above equation and I can get this as the second equation. Energy of the photon can be written as Hc by lambda. You have to put the value of H in joule second, 6.6 whatever, C in meter per second, lambda in meters, and you will get the energy of this one photon in joules. But remember, this photon, one photon has a very, very small energy. So joule may not be a good unit for this. So we have a different unit for this energy of a photon, which we are going to use very extensively in this chapter. And that unit is known as EV, electron volt. Have you heard about electron volt? 1 electron volt is 1.6 into 10 raised to the power minus 19 joules. Do you know this? Yes or no? Okay.
Yes, sir.
So most of the time that we are going to deal with this photons in this chapter, we are going to deal with energy which is going to be very small. So we are going to deal with energy in electron volts. 1 electron volt is 1.6 into 10 raised to the power minus 19 joule. Now I can put the values of Hc, lambda and everything here, and I can also put the value of how much is 1 electron volt. I can rewrite this equation in this form, and this is the form that most of the time we are going to use this equation. I can write this equation as 12375 divided by lambda in Armstrong unit, and I will get the answer of this energy in electron volt. And this is the shortcut that you have to remember. This chapter is more about shortcuts. Remaining, how many shortcuts you can learn. So from this particular shortcut, you can exactly get your energy in electron volts straight away rather than multiplying everything. This shortcut sometimes is written in this way. We take the more approximate value, 12,400 divided by lambda in Armstrong unit, and you will get your answer in electron volt. How you are going to use this? I will give you a small example of how we are going to use this this concept. No one is going to ask you. Very rarely you will get a question where they will give you lambda and they will ask you what is the energy of this photon. Very rarely you will get that question, but you may get that question. So you must know how to use this. Have you noted this down? Then I can give you a small question based on this concept. In this question, you have to find out something. Let us see what something you have to find out. Question number 1. A photon has a wavelength 2480 Armstrong unit. Find the energy of one photon. Whenever I'm writing E stands for energy of one photon. I'll give you 2 minutes to solve this. Let me know once you are done.
Sir. Sir. Sir.
Yes, beta, say.
5 electrovolts.
5 electron volts is absolutely correct. Everyone got this? Okay, that is correct. So what you got to do? This is the way you can remember what we had done and how you apply this in real senses. Okay, let me just give you a minute. Okay, so how do you do it? Let me start the camera. How do you do it? It's very simple, right? Straight away you can use the formula E is equal to 12,400 divided by lambda. Just put the values 12,400. Why this has become 0? Because of this. 12,400 divided by 2480. You can do a simple division and you will end up with 5 electron volts. Yes or no? Anyone understands this?
Yes, sir.
Okay. Let us move on to the next thing. Shall we move on?
Yes, sir.
Yes, sir.
Okay. We move on to the next thing, and the next thing let us talk about is the mass of a photon. Very rarely we will come across this mass of a photon because there is a very small thing that you must understand about the mass of a photon. The rest mass of a photon, and this has come many times in your NEET. Rest mass of a photon is 0. We all have rest mass. When we are at rest, you are at rest, I am at rest, we all have your rest masses. When we move, our mass actually decreases. But for a photon, the rest mass is 0. That means photon does not exist when it is at rest. Photon is a particle that carries light. It only moves. It only has existence when it moves. Do we understand this? It only has existence when its rest mass is 0. But sometimes we may come across this term mass of a photon. It actually means its effective mass when it is moving. So how do you find out this mass of the photon? Remember, you can just write a couple of equations, and then with this equation you should be able to find out the mass of a photon. Now E is equal to HF, that is nothing but hc by lambda. Yes or no? Also, we have E is equal to mc square, mass into c square, Einstein's equation. You know this, yes or no?
Yes, sir.
And you can also write m into
Yes,
c
sir.
will be the momentum p of the particle. So these are the three equations, and if we can just eliminate the certain quantities from 1 and 2 and 3, you can get the mass of the photon as well as the momentum of the photon. Can you tell me what will be the mass of a photon if you find out from these equations? Straight away I can find out the mass of the photon, E divided by c square. Yes or no? From the second equation, yes or no?
Yes, sir.
I can write E as hf divided by c square, or I can write it as f by c can be written as 1 by lambda. So I have this h by c lambda. You can use this equation to find the effective mass of a photon, but hardly you will come across any question which asks you the mass of an electron, a mass of a photon. But still, since it's a concept, I have told you. Do you understand this? You have noted this down?
Yes, sir.
The more important concept about a photon is not the mass, but is the second thing, which is the momentum of a photon. Momentum of a photon. What is the momentum of a photon? Momentum of photon is P, which is equal to m into c. Yes or no? Mass into c.
Yes, sir.
Then you already know what is the mass of a photon. We have calculated it in the above equations. You can just multiply all the above equations and get the momentum of this photon. Yes or no? So the first formula for momentum of the photon will become E by c. The second formula will become hf by c. And the third formula will become h by lambda. Do we understand this? Yes or no? I'll
Yes,
give you
sir.
2 minutes to think about it and write it down. Remember, these formulas may be confusing. The more you write them, the better you are with them. Have you noted it down, bacha?
Done, sir.
Yes, sir. Complete, sir.
Everyone? Okay.
Yes, sir.
Now, with this momentum of a photon, we can get into another concept. But first, let me get that concept for you. Now, what we have done here is we have calculated the momentum of a photon, right? H by lambda. But I can also write the wavelength of the photon here. So I can write the wavelength of the photon is, I can write the wavelength of the photon as h by p. Yes or no?
Sir.
Okay. I can write the wavelength of the photon as h by p. Yes or no? I can write the wavelength of the photon as h by p, where p is the momentum and h is the Planck's constant. Yes or no?
Yes, sir.
Now, this is the wavelength of a photon, and this photon is right now treated as a particle. Now, on similar lines, I can find out the wavelength of any particle. I can find the wavelength of electron, I can find the wavelength of a proton. I can find the wavelength of a neutron. I can also find the wavelength of anything that has a momentum. And from here, the concept of matter waves has come into the picture. So let me introduce that concept also here, since we are dealing with wavelength, matter waves. Some people also call it de Broglie wave. What is this matter wave or de Broglie wave? We have seen that. We have seen what? We have seen that light has a dual nature. Sometimes it behaves as a particle and sometimes it behaves as a wave. Now, on the similar concept, what we have proposed, de Broglie proposed that even a particle, which is a particle, this telephone or an electron or a proton, a moving particle which has a momentum, it can be treated as a wave. So a moving particle is also a wave. A moving particle is a wave. And such waves which are associated with particles are known as matter waves. Waves associated with particles are known as matter waves or de Broglie waves. Do we understand this? Now, since every particle is also a wave, it also has a wavelength, and that wavelength is known as de Broglie wavelength. And how do you find the de Broglie wavelength of any particle? You've just found out the wavelength of photon. From that concept, we can find out the de Broglie wavelength for any particle and will be equal to h divided by p. Do we understand this? Huh?
Yes, sir.
Or you can also find it as h divided by mv, where m is the mass of the particle and v is the velocity of the particle. Remember that particle is not photon, so it is not moving with the speed of light. So therefore, you are not divided by mc. C is the speed of light. You are divided by mv, where v is the velocity of the particle. Do we understand this, or this is going about saying bye bye? I'm going. You understand this?
Yes,
Yes,
sir.
sir.
You can also write this as h upon under root of 2 times m into k, where k is the kinetic energy of the particle. Where k is the kinetic energy of the particle. Because there is a relation between momentum and kinetic energy. Momentum is root of 2 times m into k. Do we understand this?
Yes, sir.
So from here I
Yes, sir.
can say the de Broglie wavelength of a particle is inversely proportional to its momentum. More the momentum, less is the wavelength. It is inversely proportional to the velocity if the particle is of constant mass. Is inversely proportional to root of its kinetic energy. H, remember here, it's a Planck constant. H here is Planck's constant. Now, there are a series of formulae that we have, and I will just give them as a formulae for you to remember for this matter waves. Okay. So I'll give you those formulae and you remember those formulae. Here I can add one more formula here. Sometimes whenever we are talking with, whenever we are dealing with these charged particles, to accelerate these charged particles, they are accelerated by an electric field. Have you heard about this? electron, when placed in an electric field, it will experience a force and it will be accelerated. A proton, when placed in an electric field, it will experience electric force and it will be accelerated. Yes or no? So this energy, kinetic energy that they get by acceleration in a electric field is equal to Q into V. So here I can put another formula, H divided by under root of 2m into Q into V. Where what is Q and what is V? What is Q and what is V? Q is the charge of the particle, bacha. Q is the charge of the particle, bacha. And V is the potential difference through which they are accelerated. I'll give you 2 minutes. Have you noted down everything? I'll give you 2 minutes to do this.
None, sir.
Okay. Now, once I put the value of masses, electron has a different mass, proton has a different mass, deuteron has a different mass, alpha particle has a different mass, I can get shortcut formulas for you and you can just remember them if you can. The lambda for an electron is given by this formula, even I don't remember it. So I have written it as a note. Remember, all these are in Armstrong units, 12.27 divided by under root of V. For a proton, the formula becomes 0.286 by root over V. This is also in Armstrong unit. For a deuteron, these are the questions that have come in your JEE, in your NEET. 0.202 into 10 raised to the power minus 10 divided by root over V. Armstrong, not Armstrong, yeah. Armstrong unit. For an alpha particle, it is 0.101 divided by root over V. Okay, these are for charged particles. Then there is one more particle whose lambda you might be required, lambda for a neutron. And the formula is same 0.286, but instead of here, you have energy. The kinetic energy, I must write. Kinetic energy in electron volt. And the answer will be in Armstrong unit. I don't think you will be required to use this formula. Most of the question that you will have will be based on this concept. Most of the question that you will have will be based on this concept, because the formula that I have given here is just putting the values and getting the answer sort of thing. They're very precise formulae. I don't think they would be asking you this. Give you 2 minutes anyways to note them down. Completed, everyone?
Yes, sir.
Yes, sir.
Okay, you noted it down. That is great. Then I will give you one question that you can solve based on this, so that this concept of momentum of the photon and electron and all these things get in your, and the concept is clear. This is a question number 1 in this category. An electron and a photon have the same wavelength. When I talk about electron, it is the de Broglie wavelength. When I talk about the photon, it is the actual wavelength. If P is the momentum of the electron and E is the energy of the photon, what is the value of P by E? I'll give you 2 minutes to solve this. Does but anyone got any answer? Shall I do it?
Sir, option B.
Option B, I think is correct. 3.33 into 10 raised to the power minus 9. Absolutely correct. Well done, bacha. What about the others? Where are we? In the same universe or not? Huh? Got the same answer? Well done. Good. I always compare both the NEET and the JEE students, and I always feel that the NEET ones are doing a lot better than the JEE ones. So that's a thing that comes to my mind always when I think of this. That is great. How are we supposed to solve this? Let me. Okay. How do we do this? First things first. Let us say that lambda for this electron, that will be H divided by P. Yes or no? This is
Yes,
what
sir.
I'm writing for the electron for that matter. Then energy of the photon will be hc by lambda. From here I can write the lambda will be equal to hc by E. Now this lambda is lambda for the electron, and this lambda is lambda for the photon. And as you can see, my dear friends, what is written is both are equal. That means the right hand side must also be equal. That means h by p should be equal to hc by E, a very nice equation. H and H getting cancelled. I have to find out the value of P by E, so I can say P by E will be equal to 1 by C. These questions are coming nowadays a lot. I've seen them many times in many exams. That is why I have decided to do it. Do we understand this?
Sir.
Okay, then this is a question that came in one of the previous year JEEs. So are we ready? Remember, questions are always simple, whether they come in a JEE, and this is the JEE when JEE was only JEE, it was IIT-JEE, no JEE Main, no JEE Advanced. Let's see if you can do this. The energy of a photon is equal to the kinetic energy of a proton. The energy of the photon is E. Lambda 1 is the de Broglie wavelength of the proton and lambda 2 is the wavelength of the photon. What is the ratio of lambda 1 by lambda 2? Let's see who can do this. 2 minutes you shall have. Shall I do it, bacha? Or you want more time?
You do, sir.
I do, sir.
Yes, sir.
Given up. Okay. So how do you do this? The energy of the photon, let me call this as E, is equal to the kinetic energy of the proton, let me call this as K. Huh? So now I can write this E as hc by lambda 2 because the wavelength of photon is given as lambda 2 and E is the energy of the photon. Yes or no?
Yes, sir.
See, it is so simple. So from here you can find out the value of lambda 2. It is sc by E. Difficulty is only in our heads. Difficulty is not anywhere else. Okay. Now let us find the value of lambda. This is what the value of lambda 2. Let us find the value of lambda 1. We can get the value of lambda 1 straight away. It's a proton. We can get the value of this straight away. C C C C C C C C C C C C C C C C C C C C. This one. है ना? Matter wave. That's it. You just have to apply this formula, get the answer, and stay happy. So this lambda 1 would be equal to wrong color, h divided by under root of 2m into k. Write it here. Lambda 1 is h divided by root over 2m k. And now just have to find the ratio of lambda 1 by lambda 2. So I just divide them, bacha, carefully. I just divide them carefully, lambda 1 by lambda 2. If I divide h and h will go away. Yes and no? Lambda 1 by lambda 2. So how will it come? It will come like this, root over E by 2m multiplied by C. Oh, sorry, divided by C, I guess. Yes or no? So what is lambda 1 by lambda 2 proportional to? Now give me the answer. Remember, this is constant. Mass of the proton is constant. Speed of light is constant. What it is proportional to, bacha? Tell me. What is the correct answer? The correct answer is B. So it was so simple. See? And that was the question in the IIT-JEE. See, life is simple. It's as simple as you get. It's as simple as you make it. Do we understand this? Chalo then, last question for the day. Let's see who gives me the answer. These type of questions are in fashion these days. They check whether you know the relation between alpha and beta and gamma particles. Not alpha, beta, gamma. Let us say the energy of a proton and an alpha particle is same. Now a proton is a single proton. An alpha particle is basically helium nucleus. So it has 2 protons and 2 neutrons. Ajo. It has 2 protons. It has 2 protons and 2 neutrons. And the mass of a proton and a mass of a neutron are actually almost equal. So remember this because they might not give you. Mass of an alpha particle is approximately 4 times the mass of a proton. Do we understand this? Remember this, they won't give you this information You must know this beforehand. Having given this information, now can you tell me what is the answer for this? The energy of a proton and alpha particle is same. What is the ratio of de Broglie wavelength of the proton and the alpha particle? Did we get the answer, Bacha? Okay, what I'll do is I'll give you this question as homework. Try it at home. Don't worry, you'll get the answer. Remember, these type of questions are coming, and that is the reason that we are doing this. I've seen such questions come. Such questions are coming. They will come. Try them, and we will see the solution in the next class. So I'll winding this off. I'll meet you in the next class on Monday. If you have any doubts, you can always ask me. Otherwise, take care and God bless you all.